the most important message protocol of all, the Internet Protocol. So the Internet was invented because there were lots of different organizations that had their own networks. My government lab might have mine, your university might have yours. Wouldn't it be nice if we could share information across those two networks, and so we could build a customized bridge between every two networks, but that would be a lot of work. So instead, why not have one protocol that allows computers in different networks to communicate with each other across networks arbitrarily? That was a good idea. And in particular, there are some details in the Internet Protocol that I think are quite clever. So we're going to go through some of the details. Now, you know something was a good idea when it lasts a long time and continues to be very useful even for applications that are wildly different from the original ones that were anticipated when the technology was created. So nobody knew that the internet would evolve into what it is now, but it was designed in such a way that the basic building blocks didn't have to change much over many, many years. Okay, so here's the Internet Protocol. It specifies how to transfer packets of data among networks. And a packet is just some bundle of information, a bunch of bytes. Networks, it turns out, are inherently unreliable at any point. Computers get unplugged, they get software updates that cause them not to do what they're supposed to do, and the Internet Protocol is fundamentally aware of this fact. So the structure of a network is also dynamic, not fixed. We want to be able to add more machines to it, more organizations all the time, and the Internet Protocol allows for that too. So this is a very flexible design, and one that is responsive to the fact that networks just are some things that break all the time. No system is ever going to exist to monitor or track all communications among all machines. So we want the internet to work without having some central supervision of how it's working. Okay, so these are all the ideas that went into the design of the Internet Protocol. And the Internet Protocol says, send packets from one place to another, always using the first few bytes in order to encode the following information. So this is a diagram of the Internet Protocol version 4, which is used most widely in the world. And it says the first 32 bits should look like this, the next 32 should look like this, the next 32 should look like this, and this. So we have 5 times 32 bits of required information. The first thing it says is what version it is. Now this was a great idea because that meant that we could just update the protocol as needed by incrementing this version number. And right now the internet's in transition to IP version 6, which has some new properties. But since IPv4 was the one that really created the internet and brought it to such broad scale, that's the one we'll talk about now. Okay, so you say what version if it is. Once you know the version, you know the structure of everything else. So all machines involved in the internet need to understand this layout of which bit means which. Okay, the next most important part is where to send the packet. So we have a destination IP address. That's part of the header of every packet that gets sent. So we know where to send it to. And we also want to write the source IP address, who sent this packet in the first place, because then if there's some error along the way, we know who to complain to. Okay, so these Internet Protocol addresses look something like 192.168.1.1, where each of these is a number between 0 and 255, and that all fits in exactly 32 bits. So one line, one row of this table that we've created. One of the main reasons that the world is switching over to Internet Protocol version 6 is to allow for more possible addresses. An Internet Protocol packet knows its length, so how much data is associated. Just this header isn't really enough to communicate everything. This header just tells you where the message is going, how it's encoded, and some other stuff. But then what follows in the rest of the packet is a bunch of arbitrary bytes that encode whatever information we want. And up here in the header, we know the length of this thing. And that means that the maximum length of a packet in the Internet Protocol is 2 to the 16th because we have 16 bits to encode it in. So we could have 65,000 bytes, but no more. Okay, it turns out that packets can't survive forever. We don't want it to be the case that if there's a loop in the network where one packet gets forwarded to the same machine in a cycle over and over again, that uses up all of our network and computational resources. So a packet has a finite lifespan. Every time one computer forwards a packet to another computer, we decrement this time to live. And when it gets down to 0, then the packet is just dropped. Okay, so packets are forwarded from one place to another based on the best effort. So if one machine or a router or something like that gets overloaded, then what it's going to do is just ignore the packets that are coming in and not bother to forward them. That's what we mean by best effort. So this is why networks are inherently unreliable, is that any part might just give up. So programs that use the Internet Protocol typically need some policy for handling lost packets, because some node along the network might just not bother to forward the information toward the destination as it's supposed to.